Hello and welcome. I'm your host, Allan Jude. Whether you're joining us live or watching this recording, we appreciate you joining us. If you're new to Klara, we're a team of open source experts specializing in ZFS and FreeBSD, helping companies worldwide optimize their systems and tackle complex technical challenges. If you're planning on building a new or re-architecting an existing storage pool, you should definitely get in touch with us. We can also offer support or squeeze more performance out of your ZFS or FreeBSD infrastructure. But before we jump into today's webinar, we're running a year-end promotion on our ZFS support subscription. You can save up to 35% on your first year if you sign up for a support subscription before January 31st of 2026. It's a good opportunity to secure ongoing access to our excellent engineering team, and we'll share more details with that a little bit later in the webinar. But now, on to today's session, the 12 days of ZFS. As is our year-end tradition, 12 practical lessons you can use immediately in your storage environment. And so we'll be walking through how to manage your free space reserve, how to extend snapshot retention with bookmarks, how to trace the unexpected I/O you might be having, and how to leave yourself breadcrumbs so that future you will be much happier with your past you. But please post your questions in the Zoom Q&A system as we go, and we'll be monitoring that throughout and adding helpful tips. And of course, joining me today is our co-host, Jim Salter, who's the creator of Sanoid and also the co-host with me of the 2.5 Admins podcast. Hey, Jim.
Hi, everybody. By the way, before we go any further, I want to mention real quick, Allan said something before about leaving breadcrumbs so that future you is happier with past you. I want to share that that sounds a little silly, but for some people, me very much included, that's actually a really effective approach. I accidentally discovered this year that I am a lot more likely to do good things for my own future if I think of it as doing a nice thing for someone else rather than just doing the thing that's best practice that you should do right now. If I think of it as I'm really doing a kindness for future Jim, who's a different person for me, for whatever reason, that makes me a lot more inclined to actually do it. So give that a shot. It's a little mind hack that maybe it won't work for you, but it does wonders for me.
Yeah. So getting into our content today, we have kind of four main areas that we broke our little tips down into. The first ones are about managing space. So that's just how do you regulate how the space in your pool gets used up to make sure it goes to the right place and you don't unexpectedly run out of space or have a runaway process use up all the space and cause problems for a more critical process.
Easy. Get rid of all the users. Problem solved.
Yeah. Then we'll talk about some tricks around snapshots. Snapshots are one of ZFS's top features, and there's a lot of nuance in there and really interesting things you can do and ways you can do it. Then we'll talk about tracking activity, how you can figure out why your system is so busy or who is making it so busy and how to fix that up. And then building on what we were just talking about, how you can leave breadcrumbs for either future you or future other person who has to deal with this, or just a kindness to the person who has to deal with this on call when it's not your turn. In hopes that they will do the same for you when it's your turn to be on call.
Or just, because you want to be a mensch. Either way works.
Yeah, exactly. So jumping straight in to managing space. Storage is a precious resource and we have to take care of it and use it as best we can. So running out of space can be catastrophic, right? If you're hosting VMs, a lot of hypervisors will immediately pause the VMs if they get an I/O error, because that's usually the right thing to do, because if you can't read or write to the disk, the VM might be better off pause, let you fix it and resume, than sitting there just crashing or whatever and causing who knows what to go very wrong.
You absolutely want your hypervisor to pause the VM if its drive becomes, but if it no longer has drive space available, because like Allan was saying, I mean, the operating system itself, it's going to crash almost immediately, no matter what you do, if it can't write. Because if you've ever filled the C drive on a Windows system completely full, you may notice you start getting really weird errors, and they don't make any sense. They don't usually have a whole lot to do with drive full. You just see processes say that, maybe they say that they don't have permissions to write somewhere. Maybe you get just completely spurious errors because most developers just don't think to trap for what if the root file system is completely 100% full? We should give the user a sensible error message for that. It for whatever reason, that doesn't really occur in our industry at this point. So it's kind of on you to make sure that doesn't happen, because when it does, nobody planned for it and the results can be catastrophic. Above and beyond, things are just going to start failing. You have to worry about possibilities for corruption as well. The last thing that you want is to be able to fit two out of like 20 new records that absolutely need to be written to your database as a unit to get committed while the other 18 didn't. You don't want that to happen.
Yeah, and we've even seen systems where it's not possible to log in because the disk is full,
Mhm.
because it can't create the audit trail that you logged in, so it doesn't allow it to happen. But it means you get an error telling you that's the wrong password or something when you know that is definitely the right password. And it's just like, why is login failing? It's because there's no space left on the system. And it does mean that anything you try to write can be lost because, the application needs to move on or is going to get restarted or whatever. It's trying to write to disk, but there's no space. So the data just evaporates. And that's really not what you want. So you want to make sure that doesn't happen. And, especially nowadays with the, shortage of RAM and NVMe and hard drives, you don't want to assume that you'll be able to get more drive space tomorrow. When you're running low on space, it could take 6 to 8 or more weeks for more, another set of drives that you order to actually arrive, let alone for you to provision them and get it up and running. And so being low on space is much more critical than just, oh, you know, we can get by and we'll just order more hard drives tomorrow. So to deal with that, we recommend creating a reservation on the pool, basically making an empty data set and setting a reservation to say this data set has exclusive use of something like 10 to 15% of the pool. Uh, this will do a couple of different things. The first, it will make your monitoring go off early, right? The amount of free space will get down because that 15 is considered used. It will mean that you get an alert that, hey, you're running out of space. And then you have the option of going in there and turning that reservation down from, say, 15% to 12% to free up a bit of space and give yourself room and wait for those new drives to arrive. And you can really, manage the available space and make sure it goes to the applications that need it or the users that need it, not to just whoever was writing the biggest files or whoever, gobbled it up first. It really gives you a lot more control over how the space is used.
Now, this fake data set, well, I shouldn't say fake data set, but this empty data set that basically only exists to say, hey, I get 10 to 15% of your pool, even though you never put anything in it. This isn't a new tactic or one that's limited to storage. My favorite example of this is it's a story back from the Game Boy DS days. There was a game called Brain Quest. And when the developers were working on the game, finally, the final assets come in after, months and months and months of game design, get added to the package, and they were just over the 4 MB RAM limit in the DS at the time. And everybody's panicked. Oh no, what do we do? What do we do? What do we do? Until one of the engineers grins, walks over to his computer, opens up main.cpp, and comments out this line: unsigned character insurance 10K. So this is the exact same concept as the one that one clever engineer made sure that even though people were going to overflow a little bit at the very end, he was going to have that insurance policy that he could cash out by just removing that line. That's exactly what we're talking about here with your insurance data set, where you can, cash in on that reservation that you weren't using. I will say though that honestly, you should be keeping a better idea of like what's going on with your pool. Ideally, I usually recommend to people, like, most of the time you should be at around ideally like 50% of your pool's capacity, because that gives you room to grow to the 75 or 80, at which point you need to upgrade then. If you're
Mhm.
waiting until you get all the way to the last 10% of the pool, like, you're already starting to have potential significant, performance degradation at that time. And you're also a lot closer to your hard error, like, oh crap, there's really nothing left. So while I do think that the reservation for 10 to 15 minutes of the pool is like a last ditch effort, is a great idea, I would argue that's not enough. And ideally, you probably shouldn't ever need to cash that in, because you're paying more attention to the capacity and health of your pool to begin with.
Exactly. Like if you're setting the reservation to 15%, your monitoring is going to go off when the 15% after that is already low, right? If you have, and so it's almost double. And yeah, it's really about making sure that you're not running out of space. but this does buy you that bit of insurance when somebody drops, tens of terabytes on you overnight. And make sure that you don't run into the problem of, oh crap, what do we do? But you can actively manage it even more than that. So the reservation system in ZFS isn't just for creating a data set that doesn't ever use its reservation. You can use it to do specific things, like if it's your database and it's critically important that it's able to write all those records, you can set a reservation saying, the last bit of space in this pool can't be used by anybody except the database. Make sure the database always has at least this many gigabytes or terabytes of space that no one else can have access to, so that your database will not ever fail and not ever run out of space, even if the rest of the system runs out of space. But it can also be useful if you need to make sure your audit logs or something are never the thing that runs out of space because, for example, it inhibits login if you run out of space for the audit logs.
Just to clarify, Allan, we are talking about ensuring a minimum amount of free space available for the database,
Yes.
not the total space for the data set the database resides in.
So the
Correct?
reservation would be for the total size of the data. So it's if you create a reservation of 100 gigabytes for a database, it makes sure that that 100 gigabytes can't be used by anybody but the database. If the database is using more than 100 gigabytes, then it could still run out of space.
Gotcha.
So only that 100 gigabytes is reserved for it exclusively, and then it has the same kind of free-for-all access to the rest of the space in the pool. But it makes sure that that initial number is not usable by anybody except for that data set.
So the difference then between a quota and a reservation is that the quota ensures that you don't go over a certain amount, whereas the reservation makes sure that you can get to that certain amount if you need to.
Exactly. And so there's actually two kinds of quotas in ZFS. There's a dataset quota, which limits the size of that dataset. So you can make sure your, web server logs don't ever exceed so many gigabytes of space. And then separately, there's the traditional user quotas where you can say, each user is only allowed, 100 gigabytes in their home directory. And if they need more, they'll have to ask or, actually clean up after themselves. But you can also have dataset quotas saying, these applications or whatever, regardless of what users actually own the files on those datasets. And that can be very important for certain workloads where you want to make sure that, the scratch space or the temp thing or, the video editing pool or whatever doesn't eat up all the available space on the system. So you can make sure, that data set can't have all of the space to make sure that the misbehaving people don't use up all of the space. Like Jim said, the only problem you can't solve is if only we didn't have users.
I mean, we can.
So now we get on to tricks with snapshots and how to get even more out of your snapshots. One of the biggest time savers for an administrator obviously is self-service backups, right? That magic .zfs/snapshot directory is very powerful, and it can even be exposed via Samba to take the previous versions feature in Windows. And that allows you to basically have self-service backups. So if a user accidentally screws up that important Excel file that runs the whole business, in Windows Explorer, they can right-click on the file, go to Properties, Previous Versions, and pick from any of the snapshots you have and restore, the version from before they broke the Excel. And that can save you getting a phone call to go, fetch something from the backups. And it can really save you a lot of time.
Now, with that said, there are a couple of things that I want to point out here. One is that you may not always be able to use the Samba feature to expose ZFS snapshots as previous versions. For example, if you're running, a proper Windows server in a virtual machine, there's not really any way to make that happen. However, even in that situation where, say, you've got, a full-on like actual Active Directory environment, you've got Windows application and file servers along the domain controller, and it's all just virtualized beneath ZFS with snapshots. You can't expose the snapshots to previous versions in that case. However, I would still recommend that you enable volume shadow copy on the drives of those virtual machines when they have user accessible files on them. Because what you'll quickly discover is that although the Windows generated previous versions is, it's nowhere near as reliable as ZFS snapshots. You don't get as many of them. They're not very predictable. They're harder to navigate. For us, the sysadmins, and IT professionals who know what we're doing. However, for a normal rank and file user, the ability to just easily hit a, like 85% of the time, what you want is in there, solution that they can immediately and intuitively get to themselves does absolutely still take a lot off your plate. And it's not just about your own laziness. Your users will be happier. The more you enable them to do for themselves when they would like to do it for themselves, the more popular you're going to be as the potential BOFH in the IT department.
Remember, the questions section in Zoom is open, so if you have any questions, do please shoot those in, and we'll be getting to them as we go, and some extra ones at the end if we have time.
And before we hit the next slide, there is one other thing that I wanted to say about the .zfs/snapshot special directory. It is powerful. It is handy. However, if you are the IT professional rather than the end user, please don't allow it to keep you from learning how to properly, mount and manage and manipulate snapshots. Because although I feel like the .zfs/snapshot special directory is certainly a lot more reliable than Windows Volume Shadow Copy, I have seen some issues with it. And some of them that can occur are there's more going on behind the scenes than you might realize. The directory is essentially kind of fake, and all those snapshots aren't actually mounted. But every time you try to ls one of those directories, what happens in the background is it automatically mounts that snapshot to that directory in order for you to read it. And if you don't realize that, you're just trawling through, hundreds or thousands of snapshots, you can kind of wind up creating an ugly mess. And things don't always 100% of the time work exactly the way that you wanted them to. Whereas if you know exactly, how to ZFS rollback or, ZFS mount, all the different things that you can do with a snapshot directly, treating it as a snapshot, it's not that you have to do things that way every single time, but you absolutely want to be familiar and comfortable with doing things that way.
Yep. So now we come to one of the features that a lot of people don't know about, and that is ZFS bookmarks. So a snapshot that we've just been talking about is basically a collection of all the data that was live during a certain transaction group. So when you create the snapshot, it is all the files exactly as they existed at the second you took the snapshot. And when we use snapshots for replication, we use that as a common starting point, right? The machine we're sending from and the machine we're sending to, if we're trying to do incremental replication, they have to have some snapshot in common to use as a starting point, and then ZFS can send just what has changed since that snapshot. But when you have a snapshot of, say, a snapshot from yesterday, that snapshot retains any blocks that were live when the snapshot was created, even if you've deleted them since then. So that snapshot takes up extra space for any of the blocks that have since been deleted. And while you require it to be the starting point for that replication, you don't actually need those deleted blocks in order to use it as the starting point for replication. And that's where a bookmark comes in. You can basically create a bookmark.
Minor correction. We don't need the contents of those blocks on the source for replication. We need the contents on the target. We need both sides to be able to identify which blocks. We just don't need both sides to have the contents of both blocks. As long as the replication target has the content of the blocks being referenced, it doesn't actually need the source to have that content.
Correct. And so the bookmark is just the transaction group number and not the actual data. And so it allows you on the source to free that overwritten and deleted data, but still have the common starting point to be able to replicate everything that has changed since then. And that basically allows you to keep replicating more, and keep those snapshots on the backup, but free that space on the source. And so that's just you have to have the snapshot to create the bookmark, but once you have the bookmark, you can delete that snapshot and use the bookmark as the starting point for incremental replication.
So it may be helpful to talk about what you can't do with bookmarks. What you cannot do with a bookmark that you can do with a snapshot is, for one, you can't roll back to it because there's no content there. So whereas with the snapshot on the source, you can just ZFS roll back to snapshot name and instantly be back to where you were. If you have a source and a target and you have only bookmarks on the source, but you've got the full snapshots on your replication target, in order to get the source back to where that bookmark referenced, you're actually going to have to replicate back in from the backup rather than being able to roll back directly to it. The other thing is, as we said, you can have bookmarks on your source, but the bookmarks won't do you any good on your target. So, whereas snapshots are good on both source and target, allow you to replicate in either direction at any time and allow you to roll back on either side at any time. When you're using bookmarks, the bookmarks go on the source. It has to stay full snapshots on the target, and you can no longer roll back on the source to what those bookmarks are. You have to actually replicate the snapshots back in from your backup before you can roll back.
Correct. Now maybe we could do a couple of rapid fire snapshot tips. The first one is what's called snap spec, which is a way to specify multiple snapshots. It allows you to basically delete a range of snapshots. So if you're trying to destroy snapshots and you have 100 snapshots, deleting each one at a time is a lot slower and a lot more overhead. And so you can do a range. You can, ZFS destroy pool/dataset at snapshot 1, %, snapshot 2, and that'll delete snapshot 1 and 2 and anything in between them. And so you can, delete the 10th snapshot through the 90th snapshot, and that'll keep the first 10 and the last 10 and delete everything in the middle. You can also do unbounded ranges. So you can say, snapshot 3 and everything after it. So that'll delete all your newer snapshots. Probably not what you want to do most of the time. And so you can also do pool/dataset at % last snapshot, and it'll delete snap 5 and everything that comes before it. And that allows you to just say, I only need the snapshot from last week and newer. So take everything from last week plus a day and older and delete that, and that'll free up a whole bunch of space.
Now, you might be thinking, sure, that sounds handy. I can delete 90 snapshots in a single command, but I don't mind writing a loop. I mean, I can just write a loop and, tell it to delete all the snapshots in this list. And in fact, that's the way I usually delete, large groups of snapshots because it's not necessarily usually a sequential thing for me. However, here's the place where I really find the snap specs useful. That's for a dry run delete. Maybe you're thinking about deleting, a group of like 20 snapshots because you need to reclaim space. You're in that, you're in that position where you don't have as much free space as you'd like and you're desperate to reclaim some and you're not sure what snapshots to get rid of in order to get your target free space reclamation that you need. You can use you can destroy snapshots with the dry run argument and with this range to find out in a single, fell swoop. Okay, what happens if I delete this entire 3-month period's worth of snapshots, however many they may be? Whereas individually doing a dry run against each snapshot will not give you the same answer because it's only going to tell you what that individual snapshot had for unique blocks. Whereas when you do the dry run delete with the snap
Jim is
spec
giving a
range,
spoiler for the next slide.
I'm spoiling your next slide. Well, give us
Because
the
we'll
next
get to the point
slide.
of why that's the only way to get certain information.
Yeah.
But the next tip is how to name your snapshots. The most important things to have in a snapshot, first, I think, is the timestamp. When was the
Mhm.
snapshot created? Um, Also, especially if you're doing a lot of replication, it can be really handy to have the host name where the snapshot was created to know which host made this snapshot. Because if you use just timestamps, it can be confusing if accidentally a snapshot gets created on a backup destination where it shouldn't have been created. But it has exactly the same name as the snapshot on the source, and it looks like they're the same and they're not. So having the host name in there, or at least a short version of it, can be very helpful. Also, if you are manually creating a snapshot, putting the reason why you made the snapshot in there can make it much easier to find the specific snapshot that was right before you did the thing that you're trying to roll back from, or
Yeah.
find a version of the file from before you did the thing.
Yeah, I do. I do basically two different types of snapshots. I do typically automated snapshots that, the date stamp is really the only thing that matters in the snapshot name. And I take manual snapshots. The automated snapshots always have the date stamp, like Allan said. Now, the manual ones, I'm not generally going to bother with a date stamp because, I can just get the birth time if I really need to know exactly when I created it. But like Allan said, it's going to be about why did I create this snapshot? For example, I might set Windows Server 2026 might come out, and I might set up my very first Windows Server 2026 VM and get the operating system installed, but I've done absolutely nothing to configure it yet. I've gotten right to the out of box experience thing, and I have now what's the word, Allan, for returning you to the OOBE on Windows? I forgot what they call it. It's not
This like the
normalization. It's like
It's almost sysprep, whatever that
Sys
getting called
prep,
that, but
whatever. Sys prep. You do the sys prep. So now you've got, a completely virginal, nothing installed, nothing configured, server 26. Well, I might want to keep that around to base, later VMs off of rather than having to go through the install every single time, in which case that's a gold image. So I'm going to I'm going to take a snapshot of it. I'm going to name it, snapshot at gold. And so that way I know exactly what that is. Now, future snapshots will accumulate ahead of that, but even if I wind up making that into a production VM, if I still have, the gold snapshot, I can replicate that gold snapshot off to a different data set, and I am ready to just immediately get into it and get going to set up my second Server 26 VM. I will also do things like I'm about to do a major version upgrade of some really sketchy software I don't trust that's very likely to, eat itself on the way and be very hard to repair. I will take a ZFS snapshot at pre-upgrade software package name. And if it went well, I will frequently, if it's really dodgy software I don't trust, I will then immediately manually take a snapshot, ZFS snapshot at post-upgrade sketchy software package.
yep, I can be very helpful. The next question you might have is, I'm looking at my list of snapshots, and this one snapshot is really big. What is making it so big? And that's where the ZFS diff command comes in. You can run ZFS diff snapshot A, snapshot B, and it'll show you everything that changed between them. This file was added, this file was overwritten, this file was deleted, whatever. You can also do it with just one snapshot, and it will compare to the live file system. But in most cases, if you're looking at an older snapshot, you just want to know what changed between these two snapshots so I can figure out why it's so big or what happened. And, this can be for everything from just curiosity, why is the snapshot big, down to forensics of who did what and when did this file get renamed or deleted. And, if you're going to go and restore that one file, it could be helpful to know when it was deleted and what other files maybe were changed at the same time, so that you realize, hey, I don't need to restore that one file. I actually need to restore like these 4 files that were deleted at the same time.
Where did the ransomware change all the data?
Yep. And the last one is the don't delete my snapshot feature. This one reminds me of like the lockout tags you put on heavy machinery when you're going to work on it. Or like, an electrician will put a padlock on the power shutoff after they turn it off to make sure nobody turns it back on while they're holding bare wires and so on. And so ZFS has a similar feature where you can basically put a hold on a specific snapshot. So if you put ZFS hold, I'm replicating this, or we need to save this, or this is the golden image, or whatever, on a specific snapshot. And if you try to destroy the snapshot, you will get told that, this snapshot's busy. It has one or more holds on it. This can help you make your automated system that, churns snapshot as they get older, not delete the snapshot because you manually need it. And then later, when you go and release the hold, it will get deleted at that time. And you can
Side
even
note, the reason
actually
that
do a
civilian
deferred
electricians tend
delete.
to use a padlock the way that Allan was talking about to lock out systems that they're working on actively, a lot of them are former military and are also familiar with the paper tag system and with other people's tendency to just tear off the paper tag and do what they wanted to do in the first place.
Yeah. Yeah. So now we get to the part Jim was spoiling, how you actually do space accounting on snapshots. So when you look at a list of snapshots, there's the used column, and that tells you how much space is uniquely used by that snapshot, or basically how much space you will regain by deleting that snapshot. Uh, but deleting a snapshot can have this really strange side effect of changing the use size of other snapshots around it. Because it turns out sometimes a specific block is not owned by any one snapshot, right? If you write a file, take a snapshot, take a second snapshot, and a third snapshot, and then delete the file, all 3 of the previous snapshots still contain versions of that file. So that file isn't unique to any one of those 3 snapshots. So deleting any one of those snapshots will not get you that space back. And so the used for all 3 of those snapshots might appear very small or, completely different scale than the file that you deleted. But if you delete 2 of those snapshots, and now the third snapshot is the only one that contains that file, suddenly the use size of that snapshot will shoot up by the size of that file because now that file is unique to that snapshot. And if you destroy that snapshot, you will actually get that space back. But if you had deleted those snapshots in a different order, which one got the used would change based on who was the last one holding on to that block.
Now, if you're having trouble following this, there's a very, very simple example that I think will probably clear it up for anybody who's still struggling a little with the concepts. If you create a brand new data set, it's got nothing in it, zero space used, right? Create a 1 meg file in that data set. Now it says 1 meg used. Take a snapshot. The snapshot says 1 meg used. Or
Or
actually, I
actually
think,
says 0.
yeah, it says zero. Delete the file in the live file system. Now the snapshot says 1 meg used because those blocks that you filled only exist in that snapshot, not in the live file system or any other snapshot. Now take a second snapshot without changing anything, and the snapshot goes right back to 0 used on both of your two snapshots because neither snapshot contains a single unique block. They each contain the exact same set of blocks. So each snapshot individually says 0 used. But remember, I said my little trick with the dry run destroy, snap 1%, snap 2? That's going to tell you 1 meg used because when you consider both snapshots, there are 1 meg worth of blocks that are unique to that combination of snapshots.
Exactly. So the tip here is if you run ZFS destroy -n for no up, meaning don't actually delete, just tell me what you would do, and the V
That's
for
the same
reverse.
thing as dry run, by the way. Dash
Yeah.
N and dry run mean the same thing.
Yep. And it would give you a list of all the snapshots it would delete, so you can verify that the range is getting the things you want, because in particular, the snap spec ranges are inclusive. So the snapshot you specify on either end is included in what's going to be deleted. So that might mean you need to adjust what names you use there. But at the very end, it will tell you the total amount of space you'll get back. And that will often not add up to the used column of each snapshot because if a block is common between two or more snapshots, it doesn't show up in any of them. It's just the way the accounting has to work. There's no way to know which blocks belong to every single snapshot without spending a lot of time doing I/O. And ZFS is trying to make snapshots as inexpensive as possible. So now moving on to activity tracking. So my pool seems pretty busy, and I want to know why. Who's making it busy, and what application, what data set? And so for that, there's a couple of different tools. I think IOStat. I think did you create that, Jim?
I didn't create it.
Okay.
It's on my GitHub back when I was moderating RZFS before Spez made Reddit toxic and suck. I ran RZFS, and an RZFS user created IOStat, and that user didn't have much of a development history. Didn't really have like they didn't have their own, GitHub. They just wanted to write some neat software and wrote some neat software. So I offered to host it for them, and they accepted. And now that is a GPL licensed project on my GitHub.
Yeah, so IOStat works like the regular IOStat on BSD or Linux, and kind of prints out what data set are you using how much every second. Or there's an alternative project from a FreeBSD developer called ZTop, which is a REST application that works more like Top and will show you each data set and like how many megabytes per second you're reading and writing from each one. And with both of those, you'll be able to see IOPS and bytes per second and average operation size and so on, and basically know if my pool's busy, but I can actually see that it's the database data set that's busy, or this one user's home directory, or whatever data set is busy. And once you know which data set it is, it's much easier to look at LSOF to see which who has that file open, or which user is doing it, or are the operations an unexpected size, right? If we see a bunch of really small blocks using up all these IOPS, but the throughput is low, that might normally look like the pool's not that busy, but it's using up all the IOPS, and the system is slow because of it. So it allows you to really dig in and figure out who's using all of that and where it's going. And then you can decide if, some user needs a talking to.
I find these tools particularly useful on, VM servers that are hosting a lot of virtual machines or containers. Usually I find on like a more traditional bare metal server, there's not usually as big a question of like, where all the IOPS are going. You usually have a pretty good idea. But when you've got, a VM hosting appliance, you might have an Active Directory controller, a Windows file server, 3 different application servers, potentially in different operating systems, a whole lot of unrelated projects all going on. And while in theory you could drill into every single VM and use its native process and storage performance, management tools to try to bring up a picture of what each VM says it's using of whatever resource you're concerned about, being able to use something like IOStat and just at a glance see all of your data sets, reported usage from the host perspective all in one place saves you a lot of donkey work, and it's also potentially considerably more accurate because you have to remember that when a VM tells you how many megabytes per second of storage it's using, it only knows what its side of that divide looks like, and it's not always going to be exactly the same on the host side because there's more things going on.
Yeah, for sure. If you want to know more about how to administer and monitor your ZFS servers, you should check out Klara's ZFS Basecamp. It's our centralized learning resource where we have articles on every step of ZFS from, what is a VDEV and a data set and how do I make a snapshot up through, I have this weird workload and I want to figure out where it's coming from. And it covers everything from basic stuff up to the most advanced tuning and tweaking and investigating issues. It's a great resource, includes articles, including from Jim and myself, videos, all the webinars that we've done before, white papers, everything that we have. And it makes it much easier to kind of make your journey through ZFS and find all the right resources.
It's much more productive than just staring at that oversized QR code and Om Mani Padme Om, and waiting for the knowledge to just kind of filter in from the universe. Which honestly, looking at that huge QR code, I kind of felt sucked into it.
Now on to the part we teased Vegas at the beginning, leaving breadcrumbs for yourself, how to make your future self thankful to your current self. One of the biggest things you can do is create a self-describing configuration. So use the user properties in ZFS. So, you can do things like ZFS set compression equals off on a data set, but you can also create your own properties. They're basically delimited by having a colon in the name. So you're supposed to have a namespace that often is like a domain name or something, and then colon, whatever you want to call your property, and then you can set a value to any text you want. The properties can store, I think, up to 8 kilobytes of text per property. You probably don't want to do that much in that because, when you do a ZFS get all, it really screws up if it prints 8 kilobytes of text for one property. It makes the columns really, really wide. But you can put notes on why you did a thing. So, for example, if you have a specific record set, record size, sorry, a specific data set, and you set the record size to 16 kilobytes, leave yourself a note about why you did that. Oh, this is hosting the database, or this specific VM works better with this setting. And then when someone comes around later, they'll know why you did that and not undo it or be like, how did you come up with that number? Write it down, and both future self years from now, when you've forgotten why you did it, or someone else will then know why it's like that and what to do about it. Or, if you turn compression off for a specific data set, why did you do that? Oh, the files in there aren't compressible, so let's not waste the time.
Alternately,
Or
encrypt all your secret information nobody should ever find out and bury it in ZFS user properties. Whatever.
um, especially if you're doing something dangerous or that is, not a best practice, documenting why, and maybe putting, when you should stop doing that.
Definitely.
Especially if something is temporary, putting this is temporary, we should revisit this decision on this date, means that when you see it next time, you're like, oh, that date's in the past now. We should undo the crazy thing we did that was only for that 1 week.
Also, especially if you're not a lone wolf admin, like, if you work in a team and somebody else might see what you're doing, if you do something that looks dumb, like setting sync equals disabled, but you had a good reason for it, you really want to go ahead and put that reason there where somebody who might actually see the fact that you set sync equals disabled somewhere and think, what the hell? I need to fix that, can actually immediately see, okay, that's why sync is disabled. Yeah, that sounds reasonable. I need to leave that alone. Otherwise,
Yeah.
you're going to find yourself in like config wars with other admins, at worst or at best, constantly having to explain why you did a thing to one person after another who's like, what the hell, man?
Yeah, in particular, if they undo it and that causes something not to work properly, then you're going to be very confused. Um, One practice that we have that's common is the note includes a ticket number that we can go and reference in our ticketing system to know, which customer asked for it to be this way. And, maybe a much longer explanation and all the context of why that you wouldn't necessarily want to embed all of that in the one data set. But this way you can actually have all of that documented in a ticket, and then just reference the ticket in the note. So next, we want to talk a little bit more about best practices for usefully logging changes. So one of the things you should do is keep a change log, right? Every time you're changing settings in ZFS, you should know why and how and so on. So the best practice for this is to start by documenting the current status of the pool before you changed anything, right? What did zpool status look like? What were the properties? Everything, a snapshot of what the system was like before. Then when we made the change, the date and the time, maybe, like I said, the ticket number, what the setting was before, and what you changed the setting to. So that if we revisit this change in the future and decide to put it back, we know what the old value was, because maybe the old value wasn't the default either. We're going from one non-default to another non-default, and we need to know what we might want to go back to.
Also, maybe the defaults change over the years. Maybe you used to
Yes,
be on the
definitely.
default behavior or the non-default, and now it's the other way around, and that can get kind of hard to keep track of. See all the, literally, I still see people using 30-year-old smb.conf configs that they cargo culted, back in the 90s, and they've just been blindly using it ever since. That's the kind of thing that a changelog can help you avoid. It helps you keep a little bit more mindful of what things used to look like and what they look like now and how long they've looked like what they look like now, which can, lead you to think, hey, we haven't, materially investigated this in 5 years. Maybe it's time.
Exactly. So then documenting why, we changed this because a user asked for it, or because this application worked better with it, or whatever that might be. And it might be, we're working around a bug in version X.Y.Z of this database software. When we upgrade to a version that doesn't have this bug, we don't need this setting anymore, and we can revisit and undo it. But we have to remember what the old value was in order to undo it. So then after you finish the change, you want to take another kind of config snapshot of what the pool looked like after, right? Whatever. So also, if this change gets blamed in the future for causing a problem, we can compare the system then to what the system was when you made the change and be like, actually, in the meantime, somebody made this other change and forgot to write it down, so it's not our fault. And then lastly, we want to periodically review the why for each of these changes. Is that still relevant? We've upgraded past the version of the database that had the problem, so we don't need that setting anymore. Or, this setting was just to solve a certain problem that only lasted for a week, and so we don't need it anymore. Or we changed this because in a newer version of ZFS, this new value is the default, and we want to take advantage of that now and not upgrade to ZFS yet. But once we do, we can change our documentation. We're sticking with the default, so we don't actually need this as a local change anymore, and we can erase it from our list of settings we change every time we deploy ZFS.
See again for a real world, although non-ZFS example, those cargo culted smb.conf, from decades gone by that were configured based on the idea that systems had megabytes of RAM, not gigabytes, megabytes. Well, things look a little different when you expect even a wimpy system to probably have at least, even a wimpy VM, you're usually expecting to have at least like 4 gigs of RAM. So, do you really want a 1990s smb.conf? Even though the format of the config file for Samba hasn't changed enough to make those old config files no longer function, what they were trying to do is no longer what you really want to do with the hardware that we have now, let alone the changes in the software.
Yep.
And
So
I'm sorry
before
for
we get
keeping
to
bringing up non-ZFS examples, but I feel like, these are the things that like a lot of us have definitely seen. And it's kind of helpful sometimes to say, hey, it's like this other thing. You're here for a ZFS webinar. You want to learn about ZFS. Maybe we can compare it to something that you do have a little bit more experience with. It's been around for a little longer. That's why I keep doing this.
Yep. And so before we get to our wrap up and summarize our 12 Christmas nuggets for you, just a reminder about that enterprise infrastructure support subscription. So we're having a sale until January 31st. If you sign up for our ZFS support, we can help you implement these practices, document things, have better explanations, and know which properties to change to what values to actually get that application to work better or that database to be more reliable, or how to tell that your replication is working properly and check that this entire snapshot is identical on the other side without having to do a whole bunch of manual comparing of files. And so until the 31st of January, you can sign up and get up to 35% off that monthly subscription. So to summarize, the kind of takeaways that we have are 12 key points. Number one was creating that reservation to buy you that little bit of emergency time if you unexpectedly are running low on space. As Jim said, you want to be planning to buy more space almost likely as soon as you pass like half full on the pool. You got to start having a plan of when we're going to do it and realizing that it can take more than 8 weeks for new hard drives to actually arrive based on the shortages that are happening now. And if you have to plan around budget and stuff, you got to be thinking way ahead of time. But if a huge amount of data gets dropped on you all at once, having that reservation can buy you that little bit of time to deal with it. Well, even if you're just waiting till Monday for people to come in to make them delete some old stuff or confirm that it's safe to delete this old snapshot or whatever to reclaim some space. It can buy you that little bit of time that can make a big difference between all your VMs being paused and everything working as it's supposed to.
And it's a lot less traumatic than figuring out which snapshots to destroy that you really didn't want to destroy, but you got to do something to get some space back.
Exactly. Then you can use quotas and reservations on users and workloads to keep any one person from being the person that used up all the space on the pool. Make sure that the web server logs don't fill the hard drive, and make sure that the audit logs can still write even when somebody has filled up the rest of the hard drive, and so on. Then how to do self-service snapshots using the .zfs directory, how to use ZFS bookmarks to be able to keep more free space on the source system, because ideally your backup system is probably has more space, but maybe not as performant. And you want to be able to keep a longer history of snapshots on the backup, but be able to free up that space on the primary to keep your performance up. Then we have SnapSpec, how you can manage range of snapshots so you can delete a whole bunch of snapshots at once. It is quite a bit more performant than deleting them one at a time, especially if you're deleting 90 snapshots. Using SnapSpec, you will delete all of those as one transaction. If you do them individually, you will create 90 separate transactions. And that can, if you're doing that in a tight loop, can mean the system performs worse for the amount of time it takes to do that. And then we talked about some snapshot naming best practices, like having the timestamp in there so that you can tell which snapshot is which, and the host name and the reason and anything else that you can reasonably pack in there to know which snapshot is which and which one is safe to remove and why a snapshot was created if it was manual. Then we talked about using ZFS diff to be able to compare two snapshots and figure out why one is so big or what changed between them. Using ZFS hold to make sure that your automatic retention policy doesn't delete that one snapshot that you turn out you really need. It's an automatic snapshot created, it was the one at 7 a.m. last week, and it's due to roll off because we only keep the ones from midnight into a month ago, but we really need that snapshot. It's not safe to delete it yet, so you can just throw a hold on that. And then using the no op destroy to actually be able to figure out how much space you would get back by deleting a snapshot. So before you give up that maybe, precious snapshot, when you really need the space, you can figure out which combination is going to give you an actual useful amount of space so that you don't destroy a snapshot just to reclaim, 40 megabytes of space. And it was like, well, that wasn't helpful. Then using the per dataset IO stats to find, which application or user or VM is the noisy neighbor that's slowing everything down for everyone so that you can give that user a talking to. And then using user properties to explain your dataset configuration and how to keep a useful log of the changes you make to a system so that you can know what it was and revisit those decisions as the factors around them might change in the future.
There's a little bit of overlap between number 11 and number 8 because we talked mostly about documenting things with the user properties. We didn't go into we didn't put as much emphasis on it. But ZFS hold, in addition to holding the snapshot, there is an optional reason argument. Please use it. Tell future you why you put a hold on the hourly snapshot at 11 p.m. 3 weeks ago. Otherwise, it's going to be really terrifying a month later when that snapshot's used is now enormous because it should have been destroyed long ago and it has a lot of ephemeral data, and you're not sure if you still need that ephemeral data or not. Whereas if you had put the reason argument in when you set the hold on it, you'd have a lot more confidence about whether or not it was okay to remove that hold and destroy the snapshot.
Yep. So now we have some questions. First up is Fern, who asks, is the .zfs/snapshot directory part of ZFS or part of Sanoid? It's part of ZFS. And so ZFS creates that. And then when you go into that snapshots directory and do ls, it's basically the same as using ZFS list-t snapshot-r, the dataset, and it will list all the snapshots on that in that dataset. And then when you stat each of those, it will actually mount the snapshot so that you can go in there and poke around and see what's there. But it is not the only way to do it. It is just often a very convenient way to do it and a way that doesn't necessarily require root access. You can also turn it off. There's a dataset property where you can make that directory always visible. The default is hidden, or you can turn it off entirely so it's not accessible. If you don't want users mucking in around your old snapshots or being able to cause a bunch of snapshots to get mounted.
Also, now that the
Normally, you
question has
don't
been
make it
asked,
visible.
Also, now that the question has been asked, whether that's a ZFS feature or a Sanoid feature, almost every single thing we've talked about today has been baked into base ZFS. The only exceptions that I can recall are IOStat and ZTop. Those are
Yep.
separate third-party applications you would need to install. Everything else we've discussed baked right into OpenZFS itself.
Next, an attendee asks, is the .zfs/snapshot directory enough to understand if a snapshot is consistent with a DR site? You don't have to even go that far. If you have a snapshot you've replicated to another machine and you just want to know if it's exactly the same, check the GUID, the GUID
Mhm.
of the snapshots. If they are the same, you can be sure that those two snapshots are identical on both sides. If a replication doesn't finish, the snapshot won't actually be visible. It won't actually show up in the list. And once it's finished, if the GUID is the same, you can be sure that every single block in that snapshot is exactly the same on both sides. You don't have to go in and check the modified times on a bunch of files or anything nearly as intrusive compared to just comparing the GUIDs. If they're the same,
Mhm.
that means that snapshot is the same and your replication is perfect.
And apologies for the romper room content, but somebody out there, I am certain, doesn't know what a GUID is, and that is globally unique identifier. Anytime you see that something has a GUID, that means that there shouldn't be anything else in the world that has that same number, which means that if you find something else with that same number, it's either the exact same thing or you've discovered a bug. So that's
Or
not
you've won the
only in
lottery.
ZFS. Anytime you see a GUID, you said that's what it's for. It's for being able to determine this is this unique thing. Anything that says it has this identifier, even if it's on a completely different system halfway around the world, it's the same thing.
Next, Lubomir asks, can you point to a how-to for the SMB snapshot exposure with Windows Shadow Copy? It's just a setting in Samba where you have to name your snapshots with the date in the format that Windows will understand. And so it's just a bit of a uh, time specifier. So you have to put %C, %N. But it's just like a one-line config thing that you put in Samba and make sure that it can parse your snapshot names and expose them to Windows in a way where Windows will be able to show the date and time of the snapshot. Another reason why having the timestamp in your snapshot name is so important.
It
I don't
can
have a
be a
link
little
handy, but
Yeah, it can be a little difficult getting this working, by the way, because the one thing that people usually won't tell you is that there are optional components of Samba that need to be built and compiled in order for this to work. And although FreeBSD, I believe, has traditionally included those bits in its Samba packages, most of the popular Linux distributions do not. And I have heard reports that it's possible to get the previous versions connected to snapshots on very modern versions of Ubuntu or Debian using the system packages. I cannot confirm or deny because I still have never once myself actually gotten it to work on a Linux. I kind of stopped bothering about 10 or 12 years ago because again, just it wound up being such a pain in the butt. And I was just not willing to cowboy compile Samba from source to get a working Samba package that would do the job when the one that was provided to me from the distributions would not. So be aware of that. If you're having difficulties with it and you're not a FreeBSD user, it may be kind of low level and you may need to look for an alternate Samba package that has other optional bits compiled in.
maybe one last question here. Are there any other ZFS tools that you use on a regular basis other than IOStat, ZTop, and Sanoid?
Does Syncoid count?
Um, I think
I know, Allan. You don't
yeah.
don't you use zREPL sometimes, Allan?
I use. ZX for sometimes, but I wouldn't recommend that to people. It's just that I haven't
No.
switched everything over to Sanoid yet. Um, Other tools,
Hot Tub Time Machine.
yeah,
Hot Tub Time Machine, which you just HTTM, just Google that. That's what it stands for. But this is again a project that was born out of when I was moderating our ZFS. Now I don't host this one, but HTTM is a tool that allows you to basically trawl through all of your snapshots looking for all the versions of a given file, so it can make it really easy. Well, really much easier than it would have been. For example, if you use HTTM on a data set that contains a Samba share, then you can find out all the versions of a particular file that are present and which snapshots they're present in, which can be very difficult without a tool like that because you might otherwise find yourself having to manually look through thousands of snapshots trying to compare, timestamps and file sizes for a particular file, whereas HTTM will do all that for you, give you an incursive style, text interface GUI. Would you call that a TUI, a text user interface? I don't know.
yep, that
But
is
it,
the right
it
term.
makes it a lot easier to cope with. Now, I don't usually need that tool, but like when that's a thing I need to do, that's the tool for it.
Yeah. All right. So thanks everyone for joining us. I just popped up a poll question. It'd be great if you could take a second to answer that, and maybe we can squeeze in one last question. Uh, Shivam asks, are VDEVs like the metadata and special VDEV still relevant when using an all-flash or SSD pool? It depends. If the device you would use as a special or metadata VDEV is not any faster, then, as a slug or a special is probably not that advantageous. But in the cases where you maybe have most of your flash has a larger sector size, and it will take all the large blocks, and you want to put all the small blocks on a different type or model of NVMe, that can make a difference. Um, if you have a lot of high churn, you might do a high endurance, like a 3 drive writes per day NVMe for the metadata, and the regular like 1 drive write per day NVMe's for the bulk storage. So there can be cases where it still makes sense, but in many cases, if it's not going to be faster, then there's not much point in separating it out. But if you have a really kind of stochastic workload where there's a lot of small blocks and a lot of big blocks, and you kind of want to keep them separate, it can still be useful, especially around fragmentation and so on. But it really depends. As with most of these questions, it depends on your application and your use case. There's not just a one size fits all answer for that.
The performance concerns for specials are very similar to the performance concerns for logs. If you're going to use it, it needs to have very high endurance. It needs to have very low latency. Throughput is not usually the most important thing. It's the latency and the endurance. It's not necessarily true that having a single, VDEV that's no faster than your storage VDEVs for an acceleration VDEV, like a log or a special, you may still get some benefit out of that. Or in some cases, you might make things worse, like with the special, particularly because where without the special, you would be distributing those metadata rights across the entire pool. If your special is only one VDEV and it's no faster than the individual VDEVs in the entire pool, you may actually create a worse bottleneck for yourself with the special than you would have without. Now, the one concern for the special that you don't have with the log is they are potentially dangerous. In modern OpenZFS, if you lose a log VDEV, the only thing you lose are any uncommitted dirty writes that happen to be in that log VDEV, which is only going to impact you if your system actually panics while you've got dirty writes in the log that haven't been committed out to the pool as a whole. Special, on the other hand, you lose the special, whole pool's gone with it. It's not coming back.
Yeah, the metadata about every file is in there, and without that, the pool's not usable.
That means that if you're using RAID Z3 VDEVs because you want triple redundancy for your storage, you need a 4 wide mirror for your uh,
For
for
your
your
special.
special.
Yeah,
You don't need the same. You don't have the same concern on a log VDEV or on a cache VDEV because again, losing one not traumatic, but the special you lose that, you lose the pool. So it needs at least as much redundancy as your storage VDEVs. Honestly, maybe
yeah,
preferably a little more, in my personal opinion,
exactly.
because that's also going to be most likely in the kinds of systems where you're that worried about performance to really be contemplating, adding a special, even after you've been warned of all these things. You probably have a lot of IOPS going into your metadata ops, which means that that special might be getting hit a lot harder and with like nastier operations than your storage VDEVs are, which is why I say, really, I would recommend ideally try to have one step more redundancy on your special if you're going to use it. That's easier for me because I don't use RAID Z3, so I'm not trying to tell you to use 5 wide mirrors. But like if you're doing Z2 VDEVs, I would recommend a 4 wide mirror personally if you're going to use a special.
Yep.
You need a
All right.
3 just to match the redundancy. But again,
Yep.
I would recommend exceed by one step.
Yep. So that wraps up today's session. Thank you for joining us. I hope this material gives you a bunch of ideas to go back and try in your own ZFS environment. As a quick reminder, we're running that end of year promotion on the ZFS support subscription. You can get up to 35% off, so definitely check that out. Pull up that QR code again.
Oh yeah, one more reminder about the specials and how wide you set the mirror for them. The wider you set that mirror on the specials, it will not obviously accelerate writing metadata. However, wider special mirrors will absolutely let you read metadata.
Yep, you'll get that many more
Not
IOPS on the
necessarily
read side.
faster in terms of like a single thread, but you can serve a lot more concurrent operations from a wider mirror.
Yeah, you'll get that many more IOPS on the read side. And our next webinar will be on January 22nd. Registration will open soon. Definitely check out our website or the newsletter and sign up for that, and we'll see you then. If you have any follow-up questions or want to talk to Klara about support or development for FreeBSD or ZFS, please reach out to us anytime. Thanks again, and enjoy the rest of your day.
Bye, everybody.